Hello everyone, I want us to look at these types of exponential equations. We're going to do three of them, and then I think after that you'll be fine. Right now, if you check this exponential equation, we have three terms on the left hand side of the equal sign. So it behaves like what? Like a quadratic trinomial if you check, okay? Right, so if you look at these equations, just check the exponents. Check the exponents. Like here, the exponents of 2x is 2x. If the ratio of the exponents is 2 is to 1, if you check your first term and second term, when the equation is in standard form, if the ratio is 2 is to 1, then you can use the K method. Okay, just check that first. And then if it's 2 is to 1, you know that you can use the K method, and you're going to use your knowledge about solving a quadratic trinomials. Like you can use factorization, you can even use the quadratic formula. Okay, so now here 2 to the power 2x is just the same as 2 to the power x and then squared. We have raised a power to a power here, 2 to the power x squared. And then remember this x times 2 is 2x. Remember that this law which says that x to the power a to the power b is just the same as x to the power ab. So it's just the same thing here. This is just the same as 2 to the power 2x. Okay, and then minus 3 times 2 to the power x minus 4 is equal to 0. And then now we let k be equal to 2x. Where there's 2x, we put k. We put k there, we put k there. It becomes k squared minus 3 times k minus 4 is equal to 0. And then we can factorize our trinomial here. And then negative 4, the factors of negative 4, that will give us negative 3. If we add them, should be negative 4 and positive 1. So this negative here, this one, shows us that one factor is positive, one factor is negative. And then this negative here will show us that the bigger factor is one which is negative. You see that? So we have our brackets here. Okay, so it's going to be k, and then the bigger factor is negative, so it's negative 4, and then k plus 1. Right, meaning that therefore k is equal to 4 or k is equal to negative 1. But remember that k is equal to 2 to the power x. Okay, so now where there's k, we put what? 2 to the power x. So it means it's 2 to the power x is equal to 4 or 2 to the power x is equal to negative 1. Right, we can't have a positive base raised to a power and then getting what? A negative answer. It's impossible. Okay, right, 2 to the power any number here, we're going to get a positive answer. So this one, there's no solution here, not applicable. So we're just left with this. So it's going to be 2 to the power x is equal to 4. And that 2 to the power x is equal to 2 to the power 2. Therefore, x is equal to 2. Now, if the if the bases are the same here, we can equate the exponents. We equate the exponents. So x is equal to 2. That's the solution there. Okay, let's go to the second one. Solve for x when given this equation. So what do we do here? When you're solving an equation, we get rid of the denominator. So what do we do? Remember, this is like 3 to the power x over 1 minus 6 over 1 minus 27 over 3 to the power x is equal to 0. Okay, you can even say 0 over 1 is fine. And then the LCD is 3 to the power x. So we multiply every term by 3 to the power x. So it becomes 3 to the power x times 3 to the power x. Let me just use brackets. And then minus 6, and then times 3 to the power x minus 27 over 3 to the power x times 3 to the power x is equal to 0 times 3 to the power x. So you're multiplying everything, even on the right hand side. And then 3 to the power x divided by 3 to the power x here is 1. And then 3 to the power x times 3 to the power x. We're multiplying powers with the same base. When you're multiplying powers with the same base, what do? We add the exponents. When multiplying powers with the same base, we add the exponents. So it's going to be 3 to the power x plus x minus 6 times 3 to the power x minus 27 is equal to 0 times that is 0. Right, and then this is 3 to the power 2x. 3 to the power 2x minus 6 to the times 3 to the power x minus 27 is equal to 0. Right, so if we check here, the ratio of the exponents is 2:1. So we can use the K method here because this one is just the same as, okay, you can skip this step. I'm doing this because I'm explaining. So you can say 3 to the power x squared. You can skip this step here. This one I'm doing now. And then minus 6 times 3 to the power x minus 27 is equal to 0. Then let 3 to the power x be equal to k, or k be equal to 3 to the power x. So where there's 3 to the power x, we put what? We put k there. So it becomes k squared minus 6 times k minus 27 is equal to 0. Right, so we have the factors of negative 27 that will give us negative 6. It should be negative 9 and positive 3. Remember, I said if it's negative here, one factor is negative, the other factor is positive. If it's negative here, it means the bigger factor is one which is negative. So we have our two brackets here, mean that k minus 9 or k plus 3. And then meaning that k is equal to 9 or k is equal to negative 3. But remember, k is equal to 3 to the power x. And then so it means 3 to the power x is equal to 9 or 3 to the power x is equal to negative 3. Right, you can't have a positive base raised to an exponent there and give us a negative number, so it's impossible here. So this one is out. So remaining 3 to the power x is equal to 3 squared. Therefore, x is equal to 2. Okay, right, let's do the last one. It's similar to this one, but let's just do it. So the same thing here, we multiply every term by 2 to the power x. So it's going to be 2 to the power x, 2 to the power x is the LCD there, times 2 to the power x. Use brackets. Then plus 32 over 2 to the power x times 2 to the power x is equal to 12 times 2 to the power x. Okay, 2 to the power x divided by 2 to the power x is 1, so we remain with 2 to the power 2x. When multiplying powers with the same base, we add the exponents, x plus x there. Okay, plus 32 is equal to 12 times 2 to the power x. Then what do we do here? If you check this equation, it is not in standard form. We have to write it in standard form. So it becomes 2 to the power 2x minus 12 times 2 to the power 2x, 2 to the power x, sorry, and then remember we've transposed that. And then plus 32 is equal to 0. Remember, a trinomial, quadratic trinomial, you have to write it in standard form before you solve it. Before you factorize or use the quadratic formula, it must be in standard form. It must be in this form. Ax squared plus bx plus c is equal to 0. It's called the zero principle. Right, here we can see that the ratio of the exponents is 2:1. So we can use the K method here. And then we can see that this is 2 to the power x to the power 2. So let k be equal to 2 to the power x. So it becomes k squared minus 12k plus 32 is equal to 0. Right, positive here means what? Positive means the two factors have the same sign. Okay, the two factors have the same sign. It can be negative, negative, or positive, positive. But here this negative confirms that actually the two factors are negative. So we're going to have our two brackets and then k. So it's going to be negative 8 and negative 4. Because negative 4 times negative 8 is positive 32. Negative 4, negative 8. Therefore, k is equal to 4 or k is equal to 8. But k is equal to 2 to the power x, you see? So it's going to be 2 to the power x is equal to 4 or 2 to the power x is equal to 8, meaning that 2 to the power x is equal to 2 to the power 2 or 2 to the power x is equal to 2 to the power 3. Therefore, x is equal to 2 or x is equal to 3. So both answers are fine here. Okay, right. So that's what you can do when you're solving these types of exponential equations. Goodbye.